Hey guys, we are trying to do the experiment 5, locating the earthquake. And for that, the very important thing is to look at the measuring the SP interval, which is the graph shown in the screen. And it shows the graph of P wave and S wave, as you can see that. So the first wave, which is starting right here, is called the P wave, and once it dies out, the second wave starts picking up, and that second wave is called the secondary wave. As the name indicates, it because it is coming out the first, we call it a primary wave, that is P wave. And the second one is the secondary wave, since it is coming second, so we call it a S wave. So the one which is starting at the P wave is at the 0 seconds, as you can see right here, and it keeps on going up and down and up and down, and once it reaches right here, it died out. So it is about approximately about 36 seconds, and once it died out, the S wave picked up. So the interval between the P wave starting point, the S wave starting point, we call it as SP interval, and that is 36 minus 0, which is going to be 36. So this is what you're going to use in all your the data which is provided in the next sheets. Okay, so you saw that this is 36 seconds already. And now it is the time to determine the earthquake epicenter. So for that, we are going to move on to the next sheet, which is right here. So one of the examples I'm going to show you is like you have the seismograph given at the three locations. One is Fresno, California. The second one is Las Vegas, Nevada. And the third one is Phoenix, Arizona. So we have this graphs given. So I want you to measure the SP interval. For example, for the first one I'm going to show you, you can see right here at the 0 seconds the P wave started. It started and then it died out right here. So this point right here, we call it about 36 seconds again. So 36 minus 0 is the 36. So this is where you're going to put that number 36 right here. In the similar fashion, I want you to do the same thing right here too. So it started out here and it died out right here. So I want you to find out how much is that seconds right here, and that minus that 0 is going to give you the interval. So I want you to do it for each and every graph, so which is 3 graphs. I already gave you one, so you have to do for the rest of the 2 graphs. And then once you have that graph, you are moving on to the next step, which is determining the earthquake distance. So in order to do that, you have to have the time and distance graph. So you can see that this graph is giving you a graph which shows a distance between the distance and time. And based on the distance and time, based on the distance and time graph, you could find out where exactly the earthquake, how far the earthquake is going to be from your location. Okay, so but you can see that each thing is 100, so each is like a 20 kilometers. So it is too much of distance to measure, and so the same thing is zoomed in the next graph. So which you can see in the next graph right here is the similar thing, but it is a little bit of a zoomed version of it so that we could see it in much better fashion. Okay, so what I want you to do, whatever the distances you got, like 36 is the SP interval, so whatever the other two numbers you got, so I want you to plot a graph between this 36. So you have 36 right here, right? So 32, 34, 36, and I want you to draw a line from this 36 to onto this line right here. Okay, so once you have a line right here, let me copy this and put it in paint. So you can see the same graph right here. So you do it on your sheets, okay? I just want to show you this one, that way you can see what am I doing right here. So I'm going to draw a 36, right? So which is 32, 34, 36. So I'm going to draw a line from 36 right here, okay? So from here, I'll have to extend this line to onto this x-axis. I don't want you to do so bad like this, but I want you to draw a straight line from this point to the y-axis. And I want you to find out how much is that, and this is 30. So each line is 1, 31, 32, 33, 34, 35, 36, 37, 38. So approximately about 38 seconds. So that is what you're going to use in your I mean, so actually you are supposed to put the 36 right here first and then drop a line onto this one right here, okay, because this is time and the one which you got is the time interval. So I want you to draw a line right here and then extend it to the x-axis, and that will give you the distance, which is 320, 340, 360. So you're going to put the 360 in this one right here, 360. Okay, similar fashion, I want you to look at whatever the timings you got and put that line, extend that line to x-axis and put those readings onto this. And then I want you to go to the last sheet that we have. Okay, this is the last sheet right here. And since the data given for the Vegas and Fresno and Arizona, Phoenix, right? So here, so you have to use a protractor and keep it as Phoenix as center one time and Vegas as center one time and the Fresno as the center one time. And I want you to draw 3 circles with using this protractor. And then whichever the intersecting point, you will get a graph similar to this one right here. Okay, so you're going to draw circles and the intersecting point would be the point of location. So you should get, based on your readings, you should get close to Los Angeles area. So somewhere right here, and that's what you're going to give your answer as California, Los Angeles. Okay, and that's it. This is what you have to do for your experiment 5. And if you have any questions, feel free to contact me. Thank you.